All right. How's everybody doing? Here on Thursday afternoon, just because I want to finish going over the review and we'll make sure you guys are all ready for the test that's coming up. All right, so just shout out if you're there. Just want to see who all is there, and then we'll get started. How you all doing? Hopefully everything's going all right. Just getting situated here real quick. All right. So, all right. Hearing from a few guys. Okay. So before we jump in to going over the back side of that review, I'd just like to see if you guys have any questions to start off. Anything at all that you guys want to know. Any questions about the test or just any questions in general. Could you do 11 on the practice test? 11. Yes, I'm going to go over the whole backside. Yep, going to do that. So what's the backside is 10, 11, and 12. We're going to do the whole backside. Okay? Anything else before we begin? Let's see. These wires all over the place. Anything else? Okay. All right. So then let's just jump into it because I don't see, there's only a few of you guys here, and that's fine. I bet some people probably haven't done the review themselves yet, and that's perfectly okay, all right? And so they're going to just come back and watch this later tonight or something like that, and that's perfectly fine, all right? And you guys can find the answer key. The answer key is already up on OneDrive. If you noticed, I just wanted to have that up just in case somebody wasn't able to access YouTube or anything like that. So the answer key is up on OneDrive, but let's just go ahead and jump into this. So you want to do number 11. So let's just do number 11 first, and then we can go back to number 10 after that. Normally I go in order, but hey, Sam wants to do number 11, so let's just do number 11 first. Number 11 is a nice problem here. We've got two aqueous solutions making a precipitate in an aqueous solution, so we're thinking, hey, this is going to be a double replacement reaction, which it is. We got to make sure we balance these first, and it won't even necessarily ask you. You notice that nowhere in this problem did it ask you to balance the reaction. The same thing on the actual test. I'm not going to say balance the reaction. You're just going to need to know, oh yeah, it's not balanced, so my answer is going to be wrong if I don't balance it, okay? So make sure you balance it first. So we got 3 chlorines, 2 chlorines, so we're going to put a 2 here and a 3 there to start. That gives me 3 leads, so I'll put a 3 there. That's going to get me 6 nitrates. So if I want to balance the nitrates, I'm going to put a 2 in front of here to balance the nitrates, which also gives me 2 aluminums, so I'm balanced there. Okay? All right. So once it's balanced, we can go ahead and just go through the problem and make sure we understand what in the world it is asking us. If you wanted to make exactly 1 gram of lead 2 chloride, so we want to make that product, right? That's our precipitate, exactly 1 gram. What volumes of these 2 reactants are we going to need to use? And we're going to assume 100% yield and no reactant is in excess, okay? So that's obviously in real life, you're probably not going to get 100% yield, but that's what the question's asking us. So what we're going to start with is something that we don't normally start with, and that is 1 gram, right? The amount of product, right? Because we know how much product that we want to get. So we want to figure out how much reactants that we are going to use to get that. So we're going to start off with 1 gram, and we're going to do this twice. So we have 1 gram of my lead 2 chloride, PbCl2, okay? And we're going to do a 3-step conversion, but let's just take it 1 step at a time. And let's start off with the lead 2 nitrate, okay? So before we can get to solving for the lead 2 nitrate, we need to convert this into moles, and then convert from moles of this to moles of lead 2 nitrate, and finally convert that into a volume, all right? So let's go ahead and get that molar mass of lead 2 chloride, which should be a pretty big number, but is not going to be hard to calculate because there's only 3 atoms there, okay? We have Where's PB? Right over here. So we have lead, which is 207.2, and we have 2 chlorines, so that's going to be plus 2 times 35.453. So that's going to give me the molar mass of lead 2 chloride, and I'll just write that down. I'll just put it directly in there. All right. So that's going to be, let's see, it should be on the bottom. 278.106 grams is 1 mole. Okay. And so we notice if we start with grams, we have to have grams here on the bottom. 1 mole is going to go on the top, so it's going to be converting from grams of lead 2 chloride to moles of lead 2 chloride. And then we're going to go from moles of lead 2 chloride to moles of our any one of these reactants. So we'll start with the lead 2 nitrate. So we go back to the balance reaction. If we're starting with lead 2 chloride, we're going to put 3 PbCl2 on the bottom. And then if we're solving for lead 2 nitrate, we're going to put 3 PbNO3 2 on the top, which is essentially just 3 of 3 or 1. So that's not doing much. And then last of all, we want to convert that to not a mass, but a volume. Because lead 2 nitrate, we know that that is a 0.225 molar solution. We want to go from moles to liters. So a little bit tricky here. If we're starting with moles, we want to put that moles on the bottom. So this is going to be 0.225 moles per liter. And that's going to get us an answer in liters. And if you want, you can then multiply this by 1,000 to get a volume in milliliters, but that's completely unnecessary. Okay? So we are now ready to do the calculation. Okay? That's going to be 1 divided by that molar mass, which, let me see, can you guys see this? 1 divided by the molar mass, so I'll just do the number I have in my calculator, times 3 over 3 is just times 1, so that's not important. And then finally, divided by 0.225 to get us this, 0.01. Let's just round that up, 0.0160 liters, which if we convert that to milliliters times 1,000, that's going to be equal to 16.0 milliliters. Okay? So pause right there for a second before we do the other part. What do you guys think? Does that make sense? Do you guys get what I'm doing? Okay? I'm not seeing any comments, but whatever. Let's just go and do the second part of this. And the second part we'll just go ahead and do in green. We're going to solve for we're going to do the exact same thing, but now solve for the other reactant, solve for the aluminum chloride. And once again, we're going to start with 1 gram of our lead 2 chloride. And once again, we're going to need to convert that to moles. And so if you wanted to do this as a separate step, you could have, but I find it easiest to do it this way. So 1 mole over 278.106 grams. And then now we're going to start to have some differences, okay? And so if we're starting with lead 2 chloride, of course, this 3 PbCl2 is going to go there on the bottom. And then the top is going to go the other chemical that we're solving for. That's going to be the 2AlCl3, okay? So now we've gone from grams of lead 2 chloride to moles of lead 2 chloride to moles of aluminum chloride. And last of all, we want to do the same thing, and that is divide by the molarity, which is 0.115 moles per liter, okay? So in this case, it's going to be 1 divided by 278.106 times 2 divided by 3 divided by 0.115, and that's going to get us a final answer there of 0.0208 liters, okay? Which is if we want to convert that to milliliters, just 20.8 milliliters. All right? So, what do you guys think? Does that make sense, guys? Okay. So, what I want to do is, let's pause here for a second, and I see that we have a lot more people now joining us. And did you guys have any questions at all about the test or about what I've just been going through before I do the other problems? Any questions at all? Okay. Now the sun's kind of cropping in on me, so hopefully it's not bothering you guys at all. But hopefully you guys can see this fine. I'm just going to jump back to number 10 here. We're going to go over number 10 before we go over number 12. Number 12 is definitely one that I want to comment on because there's more than one way to solve for number 12, and there's also plenty of ways to make a mistake on number 12. So I want to make sure we go back to number 12. But number 10 and 12 are also going to be important. So the test itself is going to be very, very similar to what you guys are seeing for the practice test. This is a previous year's test. Expect to see different numbers, different reactions, and the problems might be worded somewhat differently. You might need to go from a different approach, but the same kind of idea. So be flexible, but expect something very similar. All right, up to number 10. We have decomposition of hydrogen peroxide. So we've seen these decomposition reactions. I just remember very recently doing a decomposition of potassium chlorate. So similar idea. And this one is if you have hydrogen peroxide. So we've got 2 oxygens on this side, and here we've got 3 oxygens. So the best way to do this would simply be to make this into a 2 so that we can have now 4 oxygens on this side, and then this would be a 2 to have 4 oxygens on that side. And these 2 numbers must be the same, right? Because that's the only place where the hydrogens are, right? You've got 2 hydrogens here and 2 here, so these 2 numbers have to be the same. So a little bit of guess and check there, but should hopefully not be a hard one to balance for you guys. So down to the problem. We have hydrogen peroxide. It decomposes according to this reaction. You perform decomposition with 15 grams. That's a good amount, 15 grams of hydrogen peroxide, and collect 6.3 grams of oxygen. Nice. All right. So if the reaction worked perfectly, how many grams of oxygen should we collect? So this is going to be a standard grams to grams calculation. It's not limiting reagent because we have only one reactant. And so it's going to be fairly straightforward. And expect a fairly straightforward problem on the test too. So I can pretty much assure you that you'll see something similar to this one on the test. But when you come down here, you might actually see it might be a little different. I got to switch some things up, make it a little bit tricky for you guys. But for the most part, expect it to be pretty similar. All right. So you're gonna have a straightforward grams to grams one. And so let's start off with 15 grams of hydrogen peroxide. And we want to know how many grams of oxygen we should collect. One of the most common mistakes that people start off with is to start using that 6.3. Do not use that 6.3 in your calculations at this point in time, right? That would be a big mistake. What is this 6.3? That 6.3, and you can tell based on this word that comes right before it, that 6.3 is the actual yield. Okay? Now let's pause here. So Sam's asking, are grams to moles, moles to moles, and moles to grams all 3 step equations? No, you know that they're not, right? So in general, a grams to grams is going to be 3 steps. Moles to moles is just like what we did last time, right? And you'll see on the test, you'll see moles to moles questions, which are just like this, which are going to be 1-step problems, right? 1-step problems. Moles to moles are 1-step problems. And then if you have grams to moles or moles to grams, it's going to end up being a 2-step problem. And then typically when you have molarity in there, it's typically also going to be a 3-step problem, just like grams to grams. Okay? Moles to moles is 1, yeah, that's right. Yep. Okay, so back over here. Again, the mistake I see most commonly is somebody just starts off doing some calculation with the 6.3, which is a big mistake, okay? Remember what the 6.3 is, that's our actual yield. We're going to start off with this 15 grams of hydrogen peroxide and use that for our first calculation, okay? And so we are, for any of these grams to grams, we're going to use a molar mass down here, the molar mass of hydrogen peroxide. So we're going to have 1 mole in the top left, and we're going to have 1 mole in the bottom right. This is going to be the molar mass of our product, that is the molar mass of oxygen. So let's calculate the molar mass of hydrogen peroxide. You got 2 times the mass of hydrogen, which is 1.0079, plus 2 times the mass of oxygen, 2 times 15.999. And that gives us 34.0138 grams, okay? That's the molar mass of hydrogen peroxide. Now, we want to figure out how much oxygen it makes. So if we're starting out with hydrogen peroxide, then we're going to put your 2H2O2 right from the balanced reaction on the bottom, and we're solving for oxygen, so we're going to put your O2 on the top, but there's only one O2, right? Only one O2 based on the balanced reaction. Now, on the top right here, this is going to be the molar mass of your product, or the molar mass of O2, which is simply going to be your oxygen, your 15.999 times 2, okay? And that 2 comes from the subscript right there, which is 31.998. And that's it. Let's do the math in your calculators. That's going to look like this. It's going to be your 15 multiplied by numbers on the top, divide by numbers on the bottom. So divided by 34.0138 times 1 divided by 2. So all we write is divided by 2. And last of all, times our molar mass of O2. So I'll just use my previous answer there. And that is going to be 7.0555. We have 3 significant figures for that. You might think that you only have 2, but remember, those 2 significant figures are for the actual yield, and they don't affect this answer. This answer is affected by the 15.0, so we have 3 significant figures. So this is going to be 7.06 grams of O2. Okay. All right. 7.055. Yes, good job. Now, next part, what's the percent yield? Percent yield, this is when we start looking at that actual yield. Percent yield is simply going to be actual over the theoretical. And that's going to be your 7.06 grams, which is not on top, right? That's on the bottom. Oops, right? Your actual, which goes back up here, that's going to be your 6.3 grams, divided by the theoretical, which is your 7.06 grams. But I'm just going to use the number in my calculator. You're going to multiply it by 100, and that's going to get me 6.3 divided by that, and we get 0.8923. I'm going to round that off to simply 89%. Now I have only 2 sig figs. Why? Because the 6.3 has only 2 sig figs. So my answer here is going to have only 2 sig figs, or 89%. Okay? So, all right. Questions? Questions, anybody? Let's see. I am reaching to grab some water. So, why would you not round the sig figs of your 7.06? Very simply because you have 3 sig figs, because it's not limited by the 6.3. The 6.3 is only got to do with this calculation. It does not go in that calculation. So that's why we didn't round off the 7.06. Why would you take points off if we wrote 89.2? Well, really it should be 89.3, but 89.2, no, I don't think I'm going to be that mean. If you're off by 1 sig fig, I will probably let it slide, but don't be off. Be right. Okay, if we don't have the correct, okay, yeah, a lot of questions about sig figs. Don't worry about them, but do pay attention to them. Okay, so I don't, try to be close. If you're off a little bit on sig figs, not a big deal. All right. So, is that a? Yeah. Neither. It's neither. All right. So, let's jump down to the last one here. All right, and we have, oh look, this is a nice reaction. Yeah, I think I got a little creative here because I have to always come up with new reactions, and you don't see this one too often for these kinds of your honors chemistry classes, right? So this is an organic reaction. You are chlorinating. This is ethane, and you're chlorinating it with some chlorine, making hexachloroethane, which is a nasty, nasty compound, and some hydrochloric acid. Anyway, so obviously, it doesn't matter what that reaction is. It's going to be something that we're going to need to balance. This is no reaction you've ever seen in your life, right? And which is fine. We still can do this. It's not a big deal for this, all right? So we need to balance this thing, and we have look at this. This is a bit of a pain, right? But we have carbon that's balanced, so no big deal. I'm going to start with hydrogen. Why? Because I have hydrogen here and I have hydrogen here, and so it's only in two different things, whereas chlorine is in more than two different things. So I got 6 hydrogen, so I'm going to go ahead and put a 6 right here, right? That gives me 6 chlorines here, 6 chlorines there. That's a total of 12 chlorines on the right side. So I'm going to go ahead and put a 6 here in front of that Cl2, which should be everything all balanced, I believe. Okay? Now, let's check this out here. We are going to combine 5 grams of dicarbon hexahydride, right? That's kind of the IUPAC name there. And 25 grams of chlorine. Which reactant would be the limiting reagent? You must prove your answer with calculation. What is the theoretical yield of dicarbon hexachloride? So I gave you guys, I did give you guys enough information here where it's not going to be totally a struggle. So I said, it asks you already, what is the theoretical yield of dicarbon hexahydride? So you already know what you're going to be solving for. You're going to be solving for this thing. All right, you're going to be solving for the dicarbon hexachloride. Now, you could, in theory, if there weren't this very last part, and maybe I won't even, tell you that. So let's suppose you get the same exact problem minus this last part. So let's just kind of scratch it out. Let's suppose you get the same exact problem minus that last part. And then you're going to be saying, hey, Mr. Ketz, and if you were in class, you would all be asking me, hey, Mr. Ketz, what do I solve for? I don't know which problem I'm going to solve for because it doesn't tell me what the actual yield is in. So what do I solve for? But this is online, so you can't ask me, and you obviously can't ask your friends either because this is all on your own, right? So what are you going to do? You can solve for either one of those. If you just want to know what the limiting reagent is, right, you can solve for either product, as long as you solve for the same product, okay? So you can solve for either one of the products as long as you solve for the same product. What I mean is you cannot go, let's say, use the 5 grams and solve for the first product and then use the 25 grams of chlorine and solve for the second product. Then you can't compare them. You can't compare apples to oranges. It just won't work, right? So if you don't have this last part, you can solve for either product or either product. But because we do have the last part, we already know that we're going to be solving for this one. We're going to solve for the C2Cl6. Okay? So, no big deal. But, on the test, it might not have that last part, which means it's easier in that there's less calculations, but it's harder in that you need to realize that you can solve for either one. It doesn't matter. So let's just jump into it. All right? We have 5 grams of our C2H6, and we want to solve for, let's see, the theoretical yield of dicarbon hexachloride. Okay, let's do it this way. Because it doesn't tell us that it wants the answer in grams or in moles, I'm going to go ahead and just solve for moles because I'm going to save myself an extra step. You could do that, okay? You can solve for either grams or moles. Both is going to work, right? So I'm going to do that this time. All right. And if this bothers you, that's fine. Go look on OneDrive. I have the answer key where I solve for grams instead. I just want to kind of switch things up a little bit here. Okay. So the first step, we need to convert these grams into moles. So what I'm going to do is, this is going to be 1 mole on top, and then on the bottom is going to be the molar mass of your C2H6. And so let's go ahead and calculate that right here in the calculator. It's going to be 2 times the mass of carbon, or 12.011, plus 6 times the mass of oxygen, or times the mass of hydrogen, or 1.0079, which is going to get me a molar mass of 30.0694 grams. Okay, and I want to solve for the C2Cl6. So what I'm going to do is, I'm going to use the balance reaction, and if I'm starting off with C2H6, I've got one of those, and I'm going to solve for C2, this should be a 2, C2Cl6, and I should have one of those. And I can just stop there, because I can solve for moles or I can solve for grams, because it's not asking me. There's no actual yield here, and so I don't actually have to calculate percent yield, so it doesn't matter whether I solve for moles or grams. I'm just going to solve for moles. So I'm going to make this into a grams to moles problem. So let's go do the math. That's going to be 5 divided by our molar mass there, and then times 1/1, and that'll get me the answer in moles, or 0.166 moles of C2Cl6. Okay? Now, we got to do the same thing for both reactants. We have 5 grams of that, and we also have 25 grams of Cl2. And so we want to convert those grams into moles, and so we need the molar mass of chlorine, and that's going to be, because you have 2 chlorines, because it's Cl2, it's going to be 2 times your 35.453, which is 70.906 grams per mole. Okay? So, last of all, we need to convert those from moles of chlorine to moles of our product. And so that's going to be 1 C2Cl6. Those tops are going to be the same. And on the bottom, we have 6 Cl2 that are needed to make that. So that's going to be 25 divided by the molar mass of Cl2, and then divided by 6, which is 0.0588 moles of C2Cl6. Okay? So got some questions here. Wait, I'm confused. Why are there only 2 parentheses here, not 3? You could do it either way. Like I said, you could do a grams to grams problem, which is what I did on the answer key, and probably what I would recommend doing normally, but I'm being lazy. That's why. The reason is, it doesn't tell me that it wants my answer in grams or moles, so it's easier to just stop right here after 2 steps and get the moles. Okay? Yep. He's doing moles. I'm doing grams to moles. Yep. So you guys got it. You guys know what I'm doing. That's awesome. It's brilliant. You're answering my questions before, or you're answering Sam's questions before I am. So that's brilliant. All right. So what I got here, I got 2 answers. I got 2 amounts of moles of my C2Cl6. And if you don't like this, you can go and look on OneDrive. You get the answer key where I solve it a different way. And so let's just look at this. Which one is the theoretical yield? Which one is the theoretical yield? Is C2Cl6 the limiting reagent? No, it can't possibly be, because C2Cl6 is a product. The limiting reagent is either going to be this or this. It cannot be a product. Okay, so is it wrong if we solve for grams? Once again, I've answered this question like 3 times. No, it's not wrong. In fact, it's what I did the very first time I did it. It's perfectly fine to solve for grams. In fact, it's probably better, but I wanted to switch things up and be lazy here, and so I just solved for moles instead because the problem doesn't specify. So there's a lot of ways we can answer this problem, okay? And so I'm hearing some answers here. Cl2, Cl2, Cl2. Yes, Cl2 this is going to be our limiting reagent, and this right here is going to be our theoretical yield. Yes, yes, yes. And why? Why? This is limiting reagent, and this is the theoretical yield. Why? Why is this a theoretical yield? Why can't we make more than that? This is the theoretical yield. I know that because it's the smaller of the two numbers. Why can't I make more than that? Because once I make 0.0588 moles of this product, I will run out of chlorine and I literally can't make any more. It's impossible to make more. And that means the chlorine is going to be our limiting reagent. Yep. Okay. So let me go through. I'm seeing a bunch of questions here. Can you solve for grams so we can check our answers? Yeah, well, magically, guess what? I have. Like I said, it's on OneDrive, and it's also right next to me. Boom, look at that. Look at that. I already solved it on grams. And so if you want to check it out, here it is. I just didn't feel like going around and doing that molar mass again. Yeah. Yep. So, yeah. So it's on the study guide, or it's right here. Boom. Okay. Any more questions? Any more questions? It's a real bummer that we're having network issues. So I'm seeing there's a bit of a lag time, and I believe that's a problem actually with Google, because so many people are like at home now and doing stuff, whatever, like watching videos or posting videos on YouTube, and so it's just making this a little bit of more of a challenge. So pausing here. Any more questions? Is the study guide in Google Classroom? The study guide is, but the answer key is on OneDrive. I have not posted the answer key on Google Classroom. Now, would it help? So you have the answer key right here on YouTube. You have the answer key on OneDrive. Do you really need it one more spot? Do you want me to post it on Google Classroom? Because I'll do it. If you really want it on a third spot, I'll do it. Just say yes. Somebody say yes, and I'll post it. I have a question about the test. You can ask now. Now is the perfect time. Now is the perfect time, so ask. Okay, we're waiting. We're still waiting for questions. Anybody else? So if Alex doesn't want to ask, that's fine. What about the rest of you guys? Okay, here we go. For the test, is a copy being posted on Google Classroom that we can print off and then send pics in? Yeah, I think so. So I know there are some issues, and I don't exactly know what it looks like from your end, but in general, I find that it's easier if you're using a laptop, a computer, something like that, or a desktop, but it will work on your iPads. So there will be a physical copy, well, not a physical, an electronic copy of the test, which will be in a Word format, which you will get off of Google Classroom. And you can either print it up, write it out, and then take a picture and upload it back to Google Classroom, or you can do it on Notability. And what people have been telling me, so I've asked a few people that have been handing in very, very nice looking homework and quizzes. What people are telling me is what you do is you download the file to Google Docs, or you open it to Google Docs, and then you somehow convert that to Notability, and then you're going to take your Notability file and save it to Google Drive, and then use your Google Drive file to upload back onto your Google Classroom. So I know it's a lot of Google this and Google that, but I think that's going to be what works out best. Okay? All right, so a lot of questions. I guess I'm just confused how we take the test. Well, exactly like we've been doing the homeworks and quizzes. Literally, exactly like it. So it'll be posted on Google Classroom, just like the quiz. You will have a limited amount of time to do it in. This is not unlimited time. You have 45 minutes to do the test, okay? And so, unlike the quiz, you will be pressed for time. So do it quickly and do it well and then upload it. Don't be like, like you guys are when you're in class and be like, oh, hey, can I have just another 5 minutes? No, I will literally take off points if you're a minute late. Okay, post your test or upload your test on time. If you're freaking out, if you have a technology problem, then email it to me. But I don't want you to email me your test. I want you to upload it. And if you can't, if you have a technical issue, rather than waiting an hour, email it to me immediately so you're not late. I will take off points for being late. That is a threat or a promise, however you want to interpret it. Okay? Now, I'm having a whole bunch of questions here. Let me see. Let me go through these. I really don't care whether you do it on Notability or you do it as a paper copy. It really just depends on what you can do, what you feel most comfortable with. Okay? Whether you feel more comfortable doing it in Notability or doing it on paper. And if you don't have a printer, then obviously you can't print it out. Okay? But I'm fine with either one. Okay? You will not have any definitions on the test. No definitions. Otherwise, it'll be very similar. No definitions. Okay. Do we need to draw? I'm assuming that means do we need to draw on the test? You need to either write it on a piece of paper or you need to do it in Notability. It looks so much better if you actually draw it on the test of the, using the Google Docs. That looks so much better. But no, you don't actually have to do that. But what you do have to do, and I mentioned to some of you guys on the quiz, you do have to sign that you have not used or talked to anybody about this test. Okay, so you've not gotten help, or you've not given help, or you've not discussed the test whatsoever with anyone. So I highly prefer that you do it on the actual test, whether it's paper or Notability as a Google document. I highly prefer that you do it that way rather than on a separate sheet of paper. I do want your signature, okay? I definitely do want that. It's fairly easy. Awesome. How long this time? 45 minutes, one class period. I know it's going to be tight. It's not easy, but you can deal with it. This is where studying actually helps. Okay, you study not so much because you can't look back. Of course you can look back. When you take the test, take the sample test with you. Okay, take all your previous homeworks with you. Look at them. If you have only electronic versions, print them out. Okay, but if you have to look back every single question, you will waste time. Okay, so you study so that you can do this in a reasonable pace. I can finish the test probably in 10 minutes flat, but I know there's going to be some of you guys that are going to be struggling with finishing it in 40 minutes. And you need to finish it in 40 minutes because you need to have at least 5 minutes for your download and upload times. Okay? All right. How many questions is the test? It's just like the practice test, okay? Open notes. Yes, it's open notes. It is open notes. All right. I'm glad you guys got all these questions. It looks like you're appropriately nervous about the test, but you shouldn't be nervous. Nervous is not going to help. Make sure you prepare for it. You know how to solve these problems. And like I said, it's open notes. So if you forget something, just look back. No problem, okay? But make sure that you know how to solve these problems and you'll be good to go, okay? Let me reiterate, you may not talk to anyone about the test during the test. That is cheating, okay? And the best way that I can make sure you don't do that is to give you a time limit, All right. Oh, look at this, some Chinese. How's it going? How's it going? Ink2K, who's that? Hey, Boren. And then that's Gilbert and Louis. Wow, look at this. Getting some AP chemistry people. Hey, AP chemistry people, do you guys want to take the test too? When are you doing balancing equations? We already did balancing equations, but if you mean making like a totally new video, I would like to do that soon. It's just I'm bogged down here with all this transition to distance learning. My next video, if you're wondering, my next video is going to be on the coronavirus because I just think it's an important topic to talk about. All right, and then I'll get back to chemistry stuff. Okay. Can we please, you really want to take the test? Oh, that's so cute. Yeah, sure, no problem. Okay. All right, good. Now, before we get off into various random conversations, let's see, are there any more test questions? Questions about the upcoming test? Is there a live stream tomorrow? No, absolutely not. You have a test which will last the entire period and you will have zero homework over the weekend. Just do well on the test and then enjoy your weekend. No live stream, no homework, no nothing. All right, see you, Sam. Easy. All right, you too. All right, anybody else? Any questions on the test? They want homework. I know. They want to do more stuff. I guess they've watched everything on Netflix and they've done all their video games, so I guess they want more homework. I'm sorry, I got nothing extra. All right. Alex, again, I'm impressed by your Chinese. You're welcome. Can you say hi to my kids? No, my kids are not going to be on live stream. Sorry. Yep. Maybe someday we can get on Zoom, which is a little bit more private, and maybe I'll let my kids say hi, which will be, awesome. But my kids are not going to be on the live stream. All right, Gilbert, what's up? All right, so wait. 有一个东西叫什么? I'm not exactly reading that. All right, Zemo, you could take the test in like 5 minutes. No, 5 minutes would probably be tough. I myself couldn't do the test in 5 minutes. Like I said, 10 minutes is probably my time for the test. Okay, you're welcome. Google Translate. Yeah, Google Translate is always messing up on Chinese. Yeah. All right, you know what? I'm gonna stop this. I'm just gonna go chill the rest of the day and finish grading my physics stuff because because there's no more chemistry questions. So I'm done. All right, take it easy, guys.